How does a computer system represent real numbers? To identify this, we first need to establish what is a real number. So let's get a definition of a real number in here. So I would say a real number is a number with a decimal point 23.174 is a real number. 10.1, 0.23, these are all real numbers because they have a decimal point. So how does a computer store a number which has a decimal point? It has to use a form called floating point representation. So what is floating point representation then? So it's a way of storing a real number in a computer system by removing the decimal point. And in removing the decimal point, it creates two parts to the number. The first part is called the mantissa, and the second part is called the exponent. And these two parts of a floating point representation are stored separately in memory locations in RAM, but they're used together to reconstitute the number. So what I mean by that is, say we've got this number, and we'll just use a decimal number just now. So say we start off with the number 347.213. So that's our initial number and it's base 10. What the computer system would do to this, in order for it to be able to store it and represent it, it would have to remove this decimal point, this thing here. And if it just whipped that out, then the number would change value, wouldn't it, because of the place values. So that can't happen. It has to be able to be reconstituted back into 347.213. So what it does is the exponent stores how many places this decimal point has moved to put it here. Or another way of thinking about it is how many places along the number grid the number has moved so that the decimal point is here. So if we say we're going to move it 1, 2, 3, so that's positive 3 places, then the number, this 347.213, is called the mantissa, and that would be stored in a memory location, and the exponent would store 3. Now another way this number could be written is 0.347213 times base 10 to the power 3. Now you've probably seen this scientific notation in your maths class, and if you evaluate this part, you know that you're moving 1, 2, 3 places, and you end up with 347.213. So that's essentially how a computer system handles real numbers. It uses this floating point representation to split the number into two parts, a mantissa and an exponent. It does not store the decimal point. It stores the number with the decimal point removed and how many places the decimal point has moved by to remove it, so that it can be put back in when it's needed. Now the other thing about the computer system, of course, is, as we know from our earlier studies, it can only store binary. Machine code is binary, 2 digits, 1 and 0. So this decimal number here, 347.213, would actually have to be stored in a binary form. So let's look at a binary number, 101.1 0.11. How would the computer deal with this number? So it has to do the same steps, doesn't it? It has to, number one, remove the decimal point and store the number without the decimal point as the mantissa, and it has to store the number of places the point has moved or the number has removed to remove the point. And that's stored in the exponent. So let's look at this number, 101.11. We know that we need to move this number 3 places. So the mantissa of this number becomes 10111, and the exponent becomes 3. We can't express it as a decimal 3 because it's got to be turned into binary. So this 3 is actually 11. So this number could be written as 10111 mantissa times base 2 to the power, the exponent 3. And it's written in binary. The base 2 is binary. Let's have a look at the type of questions you might face regarding floating point representation of real numbers in a computer system. Here is a typical question that you might face in your exam. So it says the current meter reading of 15007.11 would be stored in a computer system using floating point representation as shown below as 0.1500711 times 10 to the power 5. This is a 2-mark answer, and what you have to do is you have to identify which part of this number is the mantissa and which part is the exponent. What you must remember is a floating point number does not store the decimal point. So don't deal with this, okay? It's just there as standard notation. The mantissa is the number without with the decimal point removed. So the answer to this mantissa is 1500711, and the exponent is here and it is 5. Now this has been written in base 10, so it's a decimal. You're not being asked anywhere in this question to convert it into a binary number. You're just being asked to identify from this number that they're giving you, can you identify the two parts of the floating point representation, the mantissa and the exponent. Here is another question. Let's have a look at it. The value 765.2 would be stored in a computer system using floating point representation as 0.7652 times 10 to the power 3. Identify the mantissa and exponent in the above floating point representation. So it's very similar to the question above. So let's identify the mantissa. So what we know so far is the mantissa is the number with the decimal point removed. So this is the number with the decimal point removed. So the mantissa is 7652. 2. And the exponent is the power. And in this instance, the exponent is 3.